Hi, this is Ms. Park. This is going to be an example of compound interest using the formula and doing the word problems. Okay, so let's read the first one. Kendra is a financial advisor. One of her clients invested $2,500 at 4.8% interest per year. Another word for interest per year is per annum. So we've seen that before. But just to show you that this interest per year is the annual interest rate. And when we looked at the formula for compound interest, it wasn't using the annual interest rate, it was using the interest rate per compounding period. So this is for the whole year. Now let's keep reading. It is compounded monthly. So that means each compounding period is a month. So this is the rate for the year, but each compounding period is a month. That means interest is going to be calculated and added into the account every month, not every year. The term of the investment is 2 years. That's how long the money is going to be there for. Determine the final amount of the investment. So let's go through this. We're going to write the formula of compound interest. And every time we use a formula, it's a good idea to write all of your variables on the left-hand side, and then we'll fill them in. And this is a good way to get organized and make sure that we're using all of the information in the word problem correctly and not missing anything. Okay, so it's asking the final amount of the investment. So that means it's asking us for the A. The principal is 2,500. That's what they put in. Now let's work on the interest rate per compounding period. The interest rate for the whole year is 4.8%. So I'm going to write that as 0.048. And that's for the whole year, but we want to know per month. So we've got to divide this by the number of months in the year. So this is now the interest rate per compounding period. N, remember, is not the number of years, it's the number of compounding periods. So that means we have to look at, there's 12 compounding periods in a year, and this investment is for 2 years. So this is my N, right? So let me write this for you. This is number of compounding periods per year. And then this 2 is the number of years. So how many compounding periods are there in this situation? There's 24. Interest is being calculated and added back into the account 24 times. So now we put all our values into here. So this is 2,500 times 1 plus 0.048 over 12 to the exponent 24. Notice I've chosen to leave this as a fraction. And the reason I do that, this actually, you can divide it nice, you get a nice number. But the reason I always leave it as a fraction is because most of the time, this fraction will give us a decimal in the calculator with repeating digits or some kind of digits. And we would, in order to write it into our formula, we would have to round. And so very, very important, never ever round until the final step of the question. All right, if we round this now, a little rounding error could make a lot of difference when it comes to money. Okay, so you have to be very careful. So just leave it in this. Our calculator can handle this whole step at once. So I'm going to enter all of this into my calculator in one step. 2,500, open bracket 1 plus 0.048 divided by 12, close the bracket, exponent 24. So notice I didn't write anything down in between. My final answer, 2751.37. So 2751.37. And actually, I can check because the answers are here. So here's my answer. It's correct. Okay. Word problem. So we have to answer in a sentence. Therefore, the final amount is with units. So dollars, 2751.37. And dollars will always have 2 decimal places for cents. Okay, so either going to answer the whole dollar or you're going to give with 2 decimal places. All right, let's do the next question. So this one says an investment earns, so what is all this? 7.75% /A. /A means per annum or per year. Okay, 7.75 is 7.75%. Compounded semi-annually. Semi-annually, semi means half, so every half year, or in other words, every 6 months. Okay, Determine the present value 5 years from now if the investment is worth $800 today. It's a little bit of a wording issue. They're saying the investment is $800 today. What was the present value, or what was the beginning amount 5 years ago? I'm going to change from now, because from now seems like it's in the future. It's actually, they mean in the past. So if it's $800 now, that's the ending amount. What was the present value or the beginning amount 5 years ago? So same formula, always the same formula for compound interest. Okay, even though there's variations of it, I'll always use the same one. My 4 variables, okay? Now they're giving us the ending amount. They're asking us for the beginning amount. The interest rate is 0.0775, so 7.75%, but we need it to be per compounding period. And since we're compounding twice in a year, every 6 months, we have to take this and divide by 2 to get the rate per compounding period, so per 6 months. And how many compounding periods? Well, we have 2 in each year because it's semi-annual, and we're doing this for 5 years. Okay, now we have everything. We'll put it in the equation here. So 800 equals P times 1 plus 0.0775 divided by 2 to the exponent 10. All right, every word problem. You start by writing the formula, then write all your variables on the left, then start inputting things into the formula. Because if you don't do that, if you get an error and you get the wrong answer, we don't know if it's that you didn't know the formula, or if you didn't get the right values that go in, or you didn't know how to put them in. So very important, write formula, write your values on the left, then put them in. Now, isolating for P, there's different ways. Probably the easiest thing to do is to just divide both sides by that big bracket. So 800 divided by 1 plus 0.0775 divided by 2 to the exponent 10. Okay, and again, calculator can handle this in one step. Okay, now everybody's calculator is different, so you have to be careful with like bracketing and stuff. You have to know your calculator. 800 divided by, I'm going to open a bracket, 1 plus 0.0775 divided by 2, close bracket, to the exponent 10. And I get 546.99, which happens to be the right answer, so that's good. 546.99. Okay, answer in a sentence. Therefore, the present value was with dollars and 2 decimal places. All right, keep practicing, please. Thank you for watching.